Classes and objects are a foundational concept of object-oriented programming, and they are extremely important in Java. So in today's lesson, we're going to learn what is a class, what are objects, how we can create classes in Java, and how classes relate to each other. Welcome to Programming with Mati. Alright, so let's start with what is a class. A class is basically a blueprint or a template for creating objects. It defines the attributes and the operations that objects of this class will be able to do. In Java, classes are declared with the class keyword, and they have fields, which are the attributes of the objects. Then you have methods that are the operations or the behaviors that the object have. And then you have the constructor, which is a special operation for creating objects. And all classes in Java inherit from a special class called object. And we'll talk about inheritance shortly. But first, let's create a class person. This class person will have the next fields and methods. It will have the first name, the last name, and the date of birth. And then it will have a method to calculate the age of the person. Alright, so I have an empty project here, and I'm going to create my first class. So I'm going to say new Java class, and I'm going to call it person. Right? So we have our person class, and you see, this is how we declare a class. Public class and the name of the class. And then we can declare the members of the class by saying the type of the member, for example, string, and then first name and the semicolon, string, last name. And we will use local date for the date of birth. These fields have a default scope of a package, which means that anything in the same package, which is com programming with Mati in this case, any class in this same package will be able to see these fields. Now, if I don't want any other class to see these fields, I could simply say private, and by making them private, I am hiding them from any other class. No other class will be able to see these members of the object. Now let's create a constructor for this class. We will say public because we want to be able to create these objects from outside. That is not always the case, but in this case we'll make the constructor public, and the constructor has the same name of the class. And now the constructor takes parameters. So I'm going to say it takes a string first name, string last name, and local date of birth. Okay, so I have declared the parameters of the constructor, and now I have to initialize the class. How do I initialize it? I say this first name equals to first name, and if you notice, this first name is the parameter first name, and this first name is the class's first name. So the object that I am creating will now have this first name that was sent as a parameter. That's why I use the keyword this to differentiate between the parameter and the name of the attribute of the field in the class. So again, I'm going to say last name equals to last name, and finally this date of birth equals to date of birth. So this seems like a lot of work, but actually I could simply remove, if I remove this, and I'll show you how IntelliJ can create for you by just doing option enter, you get the option to create a constructor with parameters. So I select the parameters and boom, the constructor is created automatically for me. So this is usually how I create the constructors. And now I'm going to create the method. So the method is going to return int, and the method will also, so we said it was going to be called age. It doesn't take any parameter because we need all the information that we need to calculate the age in here. It doesn't take any parameters because all the information that we need to calculate the age is right here, is the date of birth. So the object already has that information. So there. And methods have this syntax where you put the return type first, then you put the name of the method, and then between braces you put all the parameters. In this case, this method doesn't have any parameters because, as I told you, we have all the information we need in the object, but usually you put the parameters in here as a list separated by commas. And then methods also have a scope, and usually you want your methods to be called from any other class, so you would put them as public. Sometimes you can change this scope to be different things. For example, it could be private if it is an internal method, or it could be protected when you want to use it only inside the inheritance of this class. But we'll talk about that later. Okay, so how do I calculate the age with a local date? This is really simple. We're going to declare a variable age, and we're going to say period, which is a special class in Java, and we'll say between, and we'll add the start date, which is the date of birth, and the date of today, local date now. And this will give us a period, and then from this period we can do get years, which is an int value. And finally we'll do return age. You can notice that IntelliJ is telling me there is a warning here because this variable is not really necessary. This local variable here is redundant, so I can basically replace this variable with a return, with an inline return. Alright, so now let's try this method. I'm going to create a quick main function, and to do this you can do psvm in IntelliJ, and it will create the main block for your function, for your main function. That's really useful. And I'm going to create a new person. Okay, and let's say this person name is John and last name Smith, and local date of, and let's say he was born in 1990 on the month 3, and the day of the month 12. Okay, so and now we can print the date. You can also, a shortcut for doing system out is just write sought, and then let's say the age of the person is, and we're going to put the person here, age, and we'll call in the method age. Just to make it more clear, I'm going to call the method age here. I'm going to declare a variable, and I'm going to put the age there. So let's run this. And if my calculations are not wrong, this person is 33 years old. Yes. So we have calculated the age of this person. So in doing this, we have used a concept called encapsulation, because we are not revealing how the age is calculated to the outer world, so the world outside this class. And we don't tell how the inside of the class works. This class has things that are not visible, but because of the visible parts, we can access the age of the person. So encapsulation basically is this concept in object-oriented programming in which you hide parts of the class so that you can hide the complexity of the class, because you don't want to have this complexity exposed, so that it's easier to use the class and to do whatever the program needs to do. So a user of this class person doesn't really care how the age is calculated. They know they can access the age method, and that is good enough for them. Alright, so now I'm going to create a new method, and this method is going to say if this person is older than another person. So this would return a boolean, which is the data type that we use for true or false, because what I want to say is this person older than this one other? And I want the response to be either true or false. So is older than, and I'm going to pass a new person as a parameter. So I'm just calling them other. So I have two persons now. I have the object that receives the message, the object that I'm calling the method upon, and then the other person, which is a person that I sent as a parameter. So how do I access the object that is receiving the call? I access it with the keyword this. This keyword is not always used, and I haven't used it here, but I can use it. So it's not mandatory to be used. It's nice, and in this case it's even nicer, because it's easier to differentiate between the object that is called upon and then the other object. So I'll use the this word in this case. So how do I do this? Basically, I could say is older, let's say a variable, and this would be simply saying this age. I can access the public method is greater than other age, because other is also a person. It has the method age. So that is really, really cool, because we were able to reuse our previous method here. So you can tell the telling that one person is older than the other is really simple when we have their ages. And because this is a Boolean variable and is the result of this comparison, I can simply return this. So return this age is greater than other age. And this can return true or false. So I'm going to create a new person, and this person, Mary Swanson, and local date of, and let's say she was born in 1994. On the day 21. Let's call her Mary. And I'm going to print. So my person, I rename this John. I'm going to say is John older than Mary? And I'm going to add here John is older than Mary. And now I'm going to do the same but the other way around. Is Mary older than John? So I'm going to put here Mary and in here John. So in this case, John will be this object, right? And in this case, Mary will be the this object. And that's the difference. So I'm expecting that in this case, I will get true as an answer because John is clearly older. And in this case, I will get false because Mary is younger than John. So let's run this. And as we expected, we get the age of John. Then we get, is John older than Mary? This is true. And is Mary older than John? False. So great progress. So this is how we represent classes in UML diagrams. UML is a language for representing models like data models and programming languages. And we usually use this when we want to create a class diagram and see how classes are related to each other. So in UML, this is representing the class. For example, here we have the name of the class, and here we have the fields, and the fields have the name of the field, the colon, and then the type of the field. And then we have the minus sign signifying that they are private. Also here we have the methods, and the methods have a plus symbol because they are public. And then we have the name of the methods, the arguments or the parameters, and then after the colon we have the return type of the method. In here I by mistake I added int, but this should be boolean. So this is a very concise way to represent a class in a diagram, and it's really useful when you want to show others what your classes are. All right, so let's talk about inheritance. So inheritance is the characteristic of object-oriented programming languages where classes can inherit from other classes all its members. That means their fields and their methods. It is a transitive relationship. It means that, for example, if I have a class C that inherits from class B and class B inherits from class A, that means that indirectly class C also inherits from class A. And that is what we mean by transitive. Okay, so how does inheritance look in Java? In Java, inheritance is done only from single classes. So one class can only inherit directly from one class. It doesn't mean that it doesn't inherit from all its parents. It means that directly you can inherit from one class. And we use the keyword extends to declare inheritance. The child class will have all the members of the parent class. This means their private attributes, their protected attributes, and their public attributes, all of them will be inherited. But the child class will only be able to access those members that are protected or public. It won't be able to access the private ones, even though they will have the private attributes. So to show you how this works, let's create a new class called employee. And this new class will have two new fields. These are position and date of incorporation, and the method years in the company. And the thing is, this employee class will inherit from our person class. All right, so I'm going to create a new class called employee. And now I'm going to declare the inheritance. I'm going to say extends person. Right? So now it's telling me there's no default constructor for this class. So I'm going to have to create a constructor because I need to initialize whatever fields are in person. Even though they are private, I need to initialize them. So I'm going to create a new constructor. I'm not going to create a constructor now, but I'm going to first declare the fields. So I'm going to say private position, and I'm going to say private local date of incorporation. Okay, so now I had to create the constructor. So I'm going to follow IntelliJ's advice and add this constructor. And you see we have public employee, and it receives first name, last name, and date of birth. But I don't have them here. So how does this work? Employee is trying to initialize the fields from the person class. So to do that, I have to use the person class constructor. And I can use that with super. Super is the special keyword that is telling me that I'm using the superclass constructor. So in this case, I'm using the person's constructor. If you see, if I go here, I'm in the person's constructor. But now I need to initialize these two as well. So I'm going to add them here. So string position and local date of incorporation. And I can just simply do this position equals to position, this date of incorporation equals to date of incorporation. And that's it. So I have initialized the person's attribute, and now I have initialized the employee attributes. Now I am going to create a method which is public, and it's going to return an int, and it will tell me how many years the person has been working in the company. So years in company. Again, it doesn't receive any parameters because we have all the data that we need to calculate this inside this class. To calculate this, I'm going to say period. So return period between date of incorporation and today, local date now, and choose get years. This will return the years the person has been working in this organization. So I'm going to create a new main, and I'm going to say new employee John Smith, and the date of birth, local date of 3/12, and local date, position, let's just say software engineer, and date of incorporation, local date of, and let's say that they started working in the company in 2008, and on December 1. Okay, so now we have an employee, and we can print how many years has John worked for the company. And the answer is, we concatenate the strings with the plus symbol, employee, year, in company. Oh, I don't like this name. I'm going to refactor. Now it's years in company. Okay. Now I'm running this method. Okay, so John has been working in the company for 14 years. So that's a long way to go, John. Congratulations. And because John is a person, I can also know what is the age of John. So for example, how old is John? And you see, I can calculate John's age because John is a person. So if I run this, okay, so John has been working 14 years and he's 33 years old. So this shows you that because John is also a person, we can access persons methods. And we can, for example, let's say we have, let's copy from here, let's get Mary, which is a person, but she's not an employee. And I can, for example, do the same, like I can say, for example, is older than Mary. So I'm going to say, is John older than Mary? And I can also create a second employee, let's say employee 2, and let's call her Susan Smith as well. And let's say she's a business analyst, and she was born, no, sorry, she was born in 87, and she started working in 2010, let's say. So now we can ask if John is older than another employee. Because employees are persons, is older than receives a person, and employee is a person. I'm going to say Mary here, and I'm going to say Mary, and in here I'm going to say Susan, and sending Susan, and let's run. So we can see that John is older than Mary and is younger than Susan. And this is a great thing about inheritance. Okay, so this is how we represent inheritance in UML. So basically we have the class, and then we have the class that inherits from, this one below with a line with this kind of arrow. with this field arrow, and we refer to this relationship like this. An employee is a person. So an employee is a person. So really straightforward, and this means that an employee will have all these attributes. All right, so we talked about objects, classes, and inheritance. So I hope you like this video, and in the next video we're going to talk about interfaces, abstract classes, what are the differences, what is the interface of a class, how do we use them in Java. So I'll be waiting for you in the next video. Bye!